Alright, let's look at the homework 7.3, problem number 10, part A. Alright, we're going to use a trig substitution to evaluate this integral here. Alright, let's do that. Alright, so in this case, we're going to use the substitution x equals a tangent of theta. So we're going to do let x be a times tangent of theta. Right? Then we can go through the usual drills. Take the derivative of x with respect to theta, and we'll get a times secant squared of theta. Right? Then multiply through by d theta to isolate dx. So dx is a secant squared of theta, d theta. Alright, so let's rewrite this first. So this is going to be equal to integral. Alright, so on top we have x squared. So we just square. You have a squared tangent squared of theta. Right? Then we have plug in a tangent, so that's going to be a squared tangent squared of theta plus a squared, and quantity raise it to the 3/2 power. Then dx is the same thing as a secant squared of theta d theta. Alright, so let's try to simplify as much as possible. Alright, so here the denominator here. Alright, first I'm gonna pull out the a squared because both terms have a squared there. So a squared times 3 over 2 power would be a cubed. So this is actually just a cubed. And what's left is tangent squared plus 1 is secant squared. And a secant squared raised it to the 3/2 power is secant cubed. Alright, so we're going to put a cubed. And we have a secant cubed of theta. Alright, then we can do a bunch of cancellation. So you have a here and a squared combined. That's a cubed on top. There's a cubed on the bottom. Alright, then you have secant squared on top. Then there's a secant cubed, so I can scratch out the cube. So we have just secant of theta on the bottom. Alright, so once you clean it up, you're going to get, so this is going to be an integral. Alright, I'm going to write the tangent squared as secant squared theta minus 1. And what's left on the bottom is just a secant of theta. Right? Then we have d theta. Right? So that's that. Then I'm going to split into two fractions. So here, this is the first one. Right, so it's a secant squared divided by secant. So one of the secant cancel out. You have secant of theta. Right, minus 1 over secant is cosine. So you have a cosine of theta. Right. Then d theta. Right. Then we can find antiderivative. Antiderivative of secant of theta is natural log of absolute value of secant of theta plus tangent of theta. Right? And minus, right? Antiderivative of cosine of theta is sine of theta. So we put the sine of theta. Right? Then since this is an indefinite integral, I'm going to put plus some constant c. Right? So we got that. Then we just have to go back to x. So let's see. We have, maybe we should draw a right triangle. So here is a general right triangle. Alright, so I'm gonna put probably theta here. Alright, then using the substitution equation, so this guy, so I'm going to just divide through by a to get the tangent of theta is equal to x over a. Alright, so tangent is opposite over adjacent. So we can put opposite, which we can set the opposite to be x and adjacent to be a. And using the Pythagorean theorem, we can get that this is just a square root of x squared plus a squared. Alright. So if you want, let's see, we already know tangent of theta, so that's an easy one to find. So tangent of theta here is x over a, so we have that guy. And we also need sine of theta. Alright, so sine of theta would be, if you want sine of theta, which is going to be opposite over hypotenuse. So we have x is the opposite, and hypotenuse is square root of x squared plus a squared. Alright, so we have, so this is x over square root of x squared plus a squared. Alright, then we have to find a secant. So secant of theta is, so this is a reciprocal of cosine. So we have hypotenuse over adjacent, right? And hypotenuse is square root of x squared plus a squared, and adjacent is a. So now we know that this guy is a square root of x squared plus a squared over a. Right? Then let's clean this up. Alright, so this is going to be natural log, absolute value of, right, square root of x squared plus a squared, right, plus x over a, so x. And both of them has over a, so I'm going to put them together. Right, minus x over square root of x squared plus a squared, and plus some constant c. Right? Actually, I'm going to put c prime here and a c prime because I want to use the c for the final answer. Alright, one last thing we can do is actually, so you have a division here. We can split it as natural log of absolute value of square root of x squared plus a squared plus x, and a minus natural log of a minus x over, actually we can put the absolute value, and x squared plus a squared plus c prime. Alright, so since natural log of a is just a constant, I can probably combine natural log of a and c prime, and then I'm going to call it a constant c. Right? So therefore, what you get is natural log of, alright, so in this case, x squared plus a plus x is never negative, so we can use the regular parentheses. So it's a square root of x squared plus a squared plus x, alright, and minus x over square root of x squared plus a squared, and then plus some constant c. Right? So that's going to be the antiderivative that we're looking for. Alright, so let's type it in. Alright, so what we got was, alright, we have natural log of square root of x squared plus a squared, right, minus, let's see, was it plus? Plus x, and then minus x over square root of x squared plus a squared, right? Then plus some constant c, right? Let me double check if I'm typing correctly. Alright, so yep, looks like that's what we want. Alright, so submit for testing. Alright, it came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.